Hello everyone, this is Nathan, and today we're counting on our fingers. Now I'm sure you all know how to count from 0 to 10, but how do we count higher than 10? The answer is not with our toes, but with the binary system. To explain binary, we need to first understand the decimal system, which is what we typically use. The word decimal comes from the Latin word decimus, which means tenth. Consequently, the decimal system is base 10, so numbers are produced using 10 symbols, from 0 up to 9. 3 additional symbols are also needed: the positive sign, the negative sign, and the point. To show this notation, let's look at an example and then the general construction. Picking a number at random, how does it break down? It is positive, so there's a plus sign at the front. The first digit represents 400, or 4 times 10 squared. The second digit represents 20, or 2 times 10 to the 1. And the third digit represents 0, or 0 times 10 to the 0. Between the third and fourth digit is the point, which separates the integer part and the fractional part. Moving on to that fourth digit, this represents 0.6, or 6 times 10 to the negative 1. Lastly, the fifth digit represents 0.09, or 9 times 10 to the negative 2. A generalized decimal number is constructed with this formula. Not dwelling on the algebra too long, let's move on to the binary system. This is base 2 instead of 10, so we only have 2 symbols, 0 and 1. Let's go backwards this time, starting with the general expression and demonstrating with an example. Here's how binary is constructed, compared to the decimal system. Now let's show how this works with just the integer part of our example. In binary, this number is represented by 1101000100, and to illustrate that, let's go bit by bit. The first bit is 1, so we have 1 times 2 to the 8, or 256. The second bit is 1, so we have 1 times 2 to the 7, or 128. Third is 0, so we have 0 times 2 to the 6, or 0. The following bit is 1, so we have 1 times 2 to the 5, or 32. The fifth and sixth bit are 0, so we have 0 times 2 to the 4, and 0 times 2 to the 3, both of which are 0. The seventh bit is 1, so we have 1 times 2 squared, or 4. And lastly are 2 more 0 bits, so we have 0 times 2 to the 1, and 0 times 2 to the 0. Adding this all together, we can see how to represent 420 using a base 2 system. Now this looks more difficult to construct in binary rather than just using our base 10 system, and it is, but the upside is that we can represent binary numbers using our fingers. A finger that is down signifies 0, while a finger that is up signifies 1. With 10 fingers, we have 10 bits to work with. That means we can count from 0 all the way up to 1023. Try it at home by picking a number in this range, then convert it to binary, and use your fingers to show it. Once you've really got it down, show off your cool new skills at parties. Just avoid 132. Until next video, good night and good luck.